So today our topic in mass transfer TVIQ is gas permeation. So let's have a look at our introduction by our field host.
Hello guys! Welcome to Mass Transfer TVIQ and I'm your host today. My name is Akmam. You know what? It is interesting to know that many scientists have discovered about various methods of separation and one of them is about membrane processing. And you know what? It is more interesting when to know that gas permeation is under membrane processing. But what is gas permeation is all about? I bet all of you must be wondering now. But don't worry guys, we have Professor Fatihah to tell us everything about gas permeation. So, stay tuned!
Permeation is the penetration of permeate, such as liquid, gas or vapor, through a solid. Gas permeation concept related to the concentration gradient of the permeate, a material specific permeability, and the material mass diffusivity. Permeation is modeled by equation such as Fick's law of diffusion and can be measured using tools such as a mini permeometer.
Wow! I think that is brilliant from Professor Fatihah. Quick note for everyone. Gas permeation is mostly applied in gas separation industry such as crude biogas upgrading. Crude biogas upgrading is mandatory in order to improve crude biogas quality by reducing its content of carbon dioxide and hydrogen sulfide.
Adolf Fick studied gas transport across membrane made of nitrocellulose and formulated what is known today as Fick's first law. The significance of Fick's law is quite general, but it is interesting that membranes were the media where it was first established. In 1866, Sir Thomas Graham, the discoverer of Graham's law, had established a series of relative permeation rates across the film for a number of gases. Therefore, many other important firsts in gas permeation research, or membrane science more generally, can be attributed to Graham.
Splendid! A bit of history behind the topic. Never gets old, isn't it? So, how about we learn some theory behind this concept of mass transfer live by our researcher friend from Canada. Take it away, guys.
Thank you, Amar. Right now, I'm going to talk about the theory and the process of gas permeation. Let's talk about the theory first. Now, permeation is defined as the flux of molecules through a material normalized to the pressure gradient. Meanwhile, for gas permeation, it is a membrane separation process using a non-porous semi-permeable membrane. It is based on each gas's distinctive physical properties such as its diffusion rates. The transport occurs by solution diffusion mechanism, and membrane selectivity is based on relative permeation rate of the components through the membrane. Each component has a characteristic permeation rate in which it is a function or ability to dissolve and diffuse through the membrane. The driving force of this process is the partial pressure gradient, and the separation mechanism is the different velocity of gas permeation. How does the gas permeation work? Well, I'll walk you through based from this diagram over here. So the gas mixture feed is fed to the box in where the membrane is put. So let's say that we want to separate an oxygen from the air mixture. We know that air containing nitrogen, oxygen, and other inert gases. So the membrane selected for the process must only allow oxygen to permeate through the membrane itself. So we can only get oxygen as the permeate. We don't want nitrogen, we don't want other gases, we only want oxygen. So from the process, the feed gas is flowed through the process using the differential pressure, so the oxygen will be permeated through the membrane, so the oxygen gas permeated will become the permeate. The other gases that cannot permeate through the membrane selected earlier will become the retentate or the reject. So basically in this process it has one inlet flow, which is the feed air, and then there will be two outflow, which is the first one is the permeate, which is only the oxygen, and the second one is the retentate, which is the other gas that cannot permeate through the membrane selected earlier. That's all for the theory and the process of gas formation. Back to you, Amar.
Wonderful explanation there. Well, behind every theory, they must be validated through some calculations, right? And luckily, we have our resident mathematicians, Mr. Romari, to get us through this.
Thank you, Amma. The mechanism for transport in gas permeation is based on solubilization and diffusion. The two chemical engineering relationship upon which the equations are based are Fick's law and Henry's law. Diffusive flux through the membrane can be expressed by Fick's law related to the membrane system as Ji is equal to di over L times by difference of xim, where Ji is the flux of I, di is the diffusivity of component I, L is the membrane thickness, xim2 is the concentration of component I inside the wall of the membrane on the feed side, and xm1 is the concentration of component I in the membrane on the permeate side. In Henry's law, xim is equal to Si times by Pi, where Si is the solubility constant for component I in the membrane and Pi is the partial pressure of component I in the gas phase. Substitute the equation into the previous equation, we get this equation, where the difference in xim is changed into difference in Si Pi. Pi2 is the partial pressure of permeate side, while Pi1 is the partial pressure on the feed side. Now let the permeability be represented by Pi is equal to di times Si. Substitute this permeability equation into the previous equation. It results in relationship for the local flux through the membrane.
Wow, as expected of our mathematician. So, every concept has their own application in their respective field. Our senior engineer, IR Nazrin, will show us more about this.
Thank you, Amma. Now, we move on to its application and advantages. The gas permeation method is recognized as one of the methods that can solve an environmental problem. The example of application are separation of hydrogen from methane, removal of carbon dioxide, removal of organic solvent from air, and nitrogen enrichment from air. Besides, the method also used in industry of making fuel cell and polymer industry. Nowadays, the method commonly implemented in industry because of its advantages. There are various advantages, for instance, low capital investment, so no need to spend on other methods that have higher costs. Ease of installation and operation. This can lead to easier maintenance, easier to operate, and low cost for maintenance. Other than that, the advantages are high project flexibility, low weight and space requirement, and also low impact on environment.
Good one, IR Nazrin, but there's a major flaw of this application. Most of the time, it produces wastewater, and this must be treated before being discharged. At the very least, this is easier to be handled in this liquid form rather than its previous volatile state. Anyway, that sums up our topic today, and thanks for watching.